Hello, guys. Welcome to another episode of Cuda Education. Today, we are at the point where we're starting to render the bistro scene. So, this is initial stages. We are now starting to render our bistro scene. And as you can see, there is evidence. Here are the receipts, right? So this is a process. Previous to this step, we were rendering an orange triangle. And now, we're moving along in our process of getting the full-fledged bistro scene. Now, the bistro scene is an application that that is freely available on the Apple Metal Sample Code Library. It's called the Modern Renderer project. So Modern Renderer, one word, one thing put together. So if you go to the Apple Metal Sample Code Library, you could just Google it, and then look up Modern Renderer. You will see the project that I'm talking about. I have rendered it completely already. Just look around on my channel. You will see, or maybe even the first couple of videos of this series, of this Clean Slate series, you will see that the full-fledged bistro. But so what we did is we to learn how to do the bistro scene, what we did is we started a fresh project in Xcode. The initial videos walk you through that. So we have a fresh and clean project in Xcode. Xcode is Apple's GUI for development. So we have a fresh and clean project in Xcode, and then what we do is we slowly start to build towards the bistro scene. So the initial rendering, the initial thing that we drew was an orange triangle, and now we're in the beginning stages of rendering the bistro scene, right? So initial stages. This is our first render of the bistro scene piece of it. Obviously, the full-fledged bistro scene is a lot more advanced, and we just go step by step and try to learn things as we go. Obviously, I have friends in high places that help me in the process of doing this. We are in the modern era, and we use modern technologies, tools to help us to get to a better place. So for this particular video, this is the first video where we're rendering the bistro scene. Now, not much capability is here. Obviously, visually there's work to be done, just even with the little piece of the scene that we have here. Also, the camera doesn't work, right? So the camera doesn't, when I say it doesn't work, the camera doesn't move anywhere in the scene. So I can't use the mouse or anything to sort of move around the scene or whatever. We kind of just render something and that's it, right? But of course, we will get to that at a later date. Right now, we're just at this initial stage of rendering the bistro scene. So there was a whole process that was done. We are now officially on step 5 of the 16-step process, right? So it's 16 major steps that we have to take. We just concluded step 4, and this is the very first episode for step 5. And as you can see, this is the result of the very first step inside of step 5. So for this video, what I want to do is just go over the full plan, just sort of pseudo code, or just notes on exactly what happened, what we're trying to do, what changed. And absorb it for this particular episode. We're not necessarily going to get into code. We're just getting into the notes for what changed between the last episode where we had an orange triangle and this episode where we actually have a building and like sort of a front area, and what have you, right? So we're just taking it one step at a time, and we're just gonna go through the notes. And here are the notes. So basically, it's this guy right here. Okay, so step 5: render the bistro scene. All right. So context. Step 4 added the asset pipeline, APL asset, APL mesh, APL texture manager, but nothing calls it yet. The app still shows their orange triangle. In this step, we wire up the renderer to actually load the Bistro scene and draw it. The geometry will be rendered with normals visualized as colors. No textures yet, which proves the entire asset GPU pipeline works and produces a striking result. All right, one thing to know about this particular step and what happened in this particular step is that we didn't add any new files, we just modified files that already existed. So towards the end of step 4, we had created a lot of files and just had like shell structure of stuff, placeholder stuff, but we created a lot of files in step 4. And sort of just had it there as a standing, as a placeholder or what have you. And step 5, all we do now is we go in and we heavily modify stuff in order to get to this scene right here. All right. So that gives you a little bit of a context of what is going on the big picture side, right? So approach, keep it simple. Forward rendering with direct draw calls, no indirect command buffers, right? So we'll get into that at some point. Let's not belabor the point right here. So keep it simple. Forward rendering with direct draw calls, no indirect buffer commands. Use normals as fragment color. Avoids texture binding complexity. That comes in a later step. So we use normals as fragment color. Okay. Set up a proper vertex descriptor so Metal automatically fetches vertex attributes from separate buffers. I'll say it again. Set up a proper vertex descriptor so Metal automatically fetches vertex attributes from separate buffers. Iterate over submeshes with frustum culling per submesh. So frustum culling is basically is this piece of the scene viewable by the camera? If it is viewable by the camera, then we go through the process of rendering the stuff, of doing the submeshes and all that. But if it's not viewable by the camera, we skip it for obvious reasons. We don't want to do work that's just completely unnecessary. All right, files to modify, 2 files. All right, so we modify 2 files, APL renderer.mm, wire up mesh loading and drawing. Okay, so we have new imports in this file. So import APL mesh.h, import APL asset.h, import APL texture manager.h, import APL mesh types.h. These files already existed, right? We're just basically attaching it now. We're importing it into APL renderer.mm. Okay, so new IVARs. Or new vars, I don't know. APL texture manager, right? So texture manager is of type APL texture manager. Manages texture heap. APL mesh, then we have the variable mesh, the loaded Bistro scene. And then we have a MTL render pipeline state, and that's a mesh pipeline state. Pipeline for mesh rendering. All right, changes to load Metal with view. Create the texture manager with heap size from APL config.h. So texture heap size. So create the texture manager with heap size. Okay. And I guess this is a constant. So we define what the heap size is for the texture. Load mesh shaders. So vertex mesh shader, fragment mesh shader from default library. Create a vertex descriptor mapping. So attribute 0 is position. Float 3. Buffer index, so it's APL buffer index vertex mesh positions, and stride 12. Anytime you see stride, generally it's like move 12 spaces. This is for attribute 0 and this is what it represents. And then after those 12 spaces we have attribute 1 normal float 3, buffer index APL buffer index vertex mesh normals, and then stride 12 again. So that's like 12 slots again. Create the mesh pipeline state with this vertex descriptor. Keep the existing simple pipeline for reference /debugging. All right, changes to load assets. Replace the hard-coded triangle with mesh loading. So we're done with the 3 vertices, for the triangle. Now we're moving on to more complex stuff. So replace the hard-coded triangle with mesh loading. So we have AAPL mesh data, AAPL mesh data with file name bistro.astc.bin. I believe this was like 300 megabytes plus. And then we have our mesh, init with mesh data, device, texture manager. Remove vertex buffer and color buffer. So remove vertex buffer and color buffer, no longer needed, okay? And then changes to draw in MTK view, right? So remember we discussed MTK view and all of the details that go with this. So pass full APL camera param strut, not just view projection matrix, to the vertex shader. Yeah, I believe before we just did the vertex, we just did the view projection matrix. It was kind of like a shortcut. But now we're passing in the full camera system. Pass full APL camera params strut to the vertex shader. Set the mesh pipeline state. Bind mesh vertex buffers. Mesh.vertices at positions index. Mesh.normals at normals index. Loop over opaque submeshes with frustum culling. Right, so this is where we're basically loop over opaque submeshes with frustum color. So this is where we're skipping stuff that, it's not necessary. For each submesh, 0 to opaque mesh count. If submesh bounding sphere is outside camera frustum, skip draw index primitives with submesh index count / index begin. All right, for whatever it's worth right now, use MTL index type u unsigned int 32 for index buffer. All right, so basically we're looping over stuff, and of course we're trying to figure out this bounding sphere thing is basically axis aligned bounding boxes. So I discussed this during my Vulkan episodes, but basically it's a I guess here it's a sphere, but basically it's do you fall within the sphere or you don't? If you're outside of the sphere, then we don't render it or stuff, because obviously it's not visible to us. So that's that. This is just, I guess this is all of this right here is changes to drawing MTK view. Okay, so APL simple.metal, add mesh shaders. So .metal, anytime we see .metal, guys, we know that it's a shader. And a shader means that it's code that's running directly on the GPU. So GPU side code, GPU side instructions, we're dealing with the GPU here. Add mesh shaders. So add new structures. Mesh vertex in with attribute 0, position float 3, and attribute 1 normal. So notice that this guy and the attribute stuff we discussed earlier with the 12 strides, it comes full circle here. Mesh vertex out with position, clip position, and float 3 normal. Add new vertex shader. Vertex mesh shader. Add new vertex shader, vertex mesh shader. Takes mesh vertex in staging, and APL params buffer. Transforms position, camera params view projection matrix multiplied by in position float 4. So this is 3 positions, and then this would be the 4th. Three dimensions, and then this is the 4th. Pass normal through. Add new fragment shader, so fragment mesh shader. So remember, we removed the vertex and the remove vertex buffer and color buffer because we no longer need it, because now we're doing this stuff right here. So add new vertex shader, vertex mesh shader. Takes mesh vertex in, an pair of transform. Right, so this was the vertex stuff, and then now we do the fragment stuff, which is the color stuff, right? So add new fragment shader, takes vertex mesh vertex out, in stage in, remaps normal from that to that, normal that to that, returns a float for color. I believe this is, it's like a handoff. So you see it takes in vertex mesh in, stage in, vertex mesh, takes vertex mesh out, stage in. So this is in, and then I guess it's out from there, and it's received here. Don't quote me on this, guys, but I believe there's a relationship between the two. It's all part of the whole pipeline conversation, right? Keep existing simple shaders, vertex simple shader, fragment simple shader for potential future use. No new files. Everything is wired into existing files. The infrastructure from step 4 does the heavy lifting. What it basically means is that we added in all the necessary files in step 4. So in step 5 now we're just, updating stuff, changing stuff, removing, structures and variables and items and stuff, and just making it to what we want it to be, so that we get our render. Verification, build the project, 0 errors, run the app, should display the Bistro scene geometry with normals as colors. A colorful visualization where surface direction determines hue. The camera is already positioned inside the Bistro scene, position this, and that, right? And that's basically it, guys. That's it. And with that, we get our scene right here. So initial stages, guys, obviously what I hope to do is to tinker with all of the settings. Like, for example, I want to frustum curl everything, right? So if I frustum curl everything, like, just tinkering with it, then we won't see anything, because as far as the application is concerned, the camera is not, it's not viewing anything, any part of the Bistro scene, so therefore it wouldn't render anything, right? So definitely want to mess with that. I want to mess with the vertex and the fragment shader. I do want to mess with, let's see what I want to mess with. What if I set the texture heap size to, what if I set the texture heap size to 0? What will that do? Do we get no textures? Do we get an error? Do we get a problem? What else could we mess with? Normals as fragment color. We'll see about that. I'm going to see if I could corrupt this right here. I want to see if I could corrupt this. So maybe put this to stride 6 and then do this to stride 18 and see if, like, the application even runs. Changes to load assets. I don't know if I'll be able to mess with this. So you see mesh in and then vertex mesh out. I definitely want to mess with this. Remaps normal from this to this. What happens if it's not remapped? Yeah. So we have our work cut out for us, guys. But welcome to step 5. Again, we are in. Maybe I could tinker with the camera. I could tinker with the camera position to see if I get more of the building or something, right? Render the bistro scene, right? So maybe if I tinker with the coordinates for the camera, I would actually see more of the building, because I'm gonna assume that like more stuff, like if I move the position of the camera just as the initial view, that I would see more of the building. So I definitely want to tinker with that just to see, how everything behaves and all of that stuff. We definitely have our work cut out for us, guys. But welcome to step 5. Thank you for watching Cuda Education. If you're new to the channel, definitely um, definitely catch up to where we are. This is the Clean Slate series. I'm gonna start. Yeah, I have a numbering system and all of that. So basically, everything in this is gonna be the start of a new number in the Clean Slate series, and then every additional video in this stage is gonna be an additional number. Kind of like software versions and stuff. But yeah, guys, thank you for watching this Good Education. Help the channel out. You know what to do. Tell your friends. Build your community. You could all learn Apple Metal by yourself. If you know anyone that's artistically inclined, you know what to do. Get them involved. Definitely, if you are in the Apple ecosystem, if you're running Apple hardware, definitely you'd want to get involved in this. This Metal stuff runs on tvOS, Vision OS, iOS, Mac OS, and any other kind of OS that is going to come out in the future, right? It's a computer graphics platform for Apple products. Okay, so thank you guys for watching. Have a great day.